Hello, I'm Nobby. Welcome to my workshop. The next part of the PM Research engine build, I'm going to tackle the cylinder. I think I need to do this part next because there are still a couple of other parts to be made which really rely on having the cylinder made before I can go ahead with that. So here we've got the cylinder, and here are the two cylinder end caps. There's a lot of operations to do on this. There's probably about half a dozen different stages of machining this, but I think the first thing to do is actually to bring this to length here. They give a measurement of 1 1/8 inches across here, which is 1.125. So I'm going to do this part in the milling machine, so I can set this up in the milling machine and machine this surface off. I think what I'll probably do is set this up in the milling machine against a V block, so I can hold this nice and square. I did have a check along the sort of shapes on here, which are sort of cast into here, and it does appear that the height of these ends are the same as these little parts in here. These obviously are only put in here for basically for appearance, so I think if I set this up into the V block and then machine off the surface here, and then that can be turned over and the other side machined. The machining I think is sort of partly to clean up each side. There's not an awful lot to come off. In fact, I put a couple of little Sharpie marks there as a rough guide for myself on how much is actually machined off on each side, just purely as a guide. Once that's done, the next procedure I think will be boring out this hole here to take the piston. It's the plans show boring this out to a 1/2 inch and reaming 1/2 inch. Other than doing that part on the lathe, there's no other way I could actually ream it, because the 1/2 inch reamers I've got a couple of them, are actually too long to be used comfortably in the milling machine. So I'm going to do the facing off here and then have a sort of a bit of a rethink on how to do that. So it not only needs a 1/2 inch hole here, which will be the actual cylinder, it will also need a 1/4 inch hole about here, that's in this position here, for the piston valve, and they give you a distance from the centre here to the centre of the piston valve, which I think was 3/4 of an inch. Now, I mean, ideally, if I could do this in the milling machine, I could then use the DRO to measure off the distance out here to where the piston valve goes. That would be an easy way of doing it if it's possible to set this up. Looking at each end, the cast hole in here, you look through it is quite rough inside there, but I'm sure it's not an illusion, but I don't think the hole here is actually in the centre. I did measure as best I could across here and across here, and they are different measurements, so that's another thing to get round as well. But I think once I've machined this off visually, it's going to give me a better idea to see exactly where I am with the hole that's in here. because when this is set up for casting, that they obviously use a core through here to give you that hole in the centre, and really, from what casting I've seen, there's really no excuse not to get that actually in the centre. The core can be made very accurately, and the this would be a sort of, the pattern would be in two halves. You see you've got a sort of pattern line here, so setting it up, this should have been set up very accurately, so that hole should have been exactly in the middle. But as I say, what I'll do is I'll face these surfaces off and then do some more measurements and see if I can determine if that hole is actually in the middle. Anyway, I'll get to the milling machine and set this up, and then perhaps bring you back for a bit of this work. I'll put a Sharpie mark on here because this end looks like the one that's got the hole actually in the centre, but whether it's my imagination or not, I don't know. Right, well, I've got the cylinder set up in the mill vise. I'm using my machinist vise because it has much deeper jaws, so I can get, hopefully a better grip on everything. And I'm using my V block at the back here, so I've got the cylinder tightly fitting into the V of the V block, and this side, the moving jaw, has a V in here as well. I tried lots of different ways to set this up. At one stage I got the front corners of the V into these little shapes here, but to me it looked as though it was sort of throwing the cylinder slightly out of level. So I know that the V block is not in sort of line with the rest of the mill, which would be this way. It's at an angle, but I think in terms of facing off, that really doesn't matter too much at all. And to set this up, I tried all sorts of different ways to make sure this is level. I've used one of my best machinist squares in the side here to level the side of this against the base. Try to make a lot of visual checks, and I've measured the height from here to the top at both sides to hopefully get it as level as I possibly can, because obviously you want at the end this face here to be sort of perpendicular to the hole that's going to be drilled through here. So I'm just hoping I've got everything as level as I possibly can. So here goes. I'm now going to sort of machine across the surface here. I've got a little reference mark here that I can machine down to. I guess the measurement of the height of this is important, and getting it equal at both sides is important as well. So I'm going to try and make as many measurements as I can. What I'm going to do is bring the cutter down to sort of touch off on here first, and then set the DRO. So I'm going to machine down and sort of try and make as many measurements as I can along the way to get this to an accurate depth. So let's see how we get on. I'll make perhaps a couple of passes on camera and then sort of do the rest off, because I do need to concentrate very carefully, obviously, on what I'm doing here. We'll bring the cutter down so I can touch off on here. and just doing this sort of by feel basically. Just set the DRO and then we put a little cut on and then see how we get on. Obviously I'm going to have to make well, it's a 12mm cutter, which wouldn't I don't think would cover that whole surface. So I'm obviously going to have to make a number of passes to ultimately level all of this up. Okay, well I'm going to carry on with this until I can get this machined off nice and level. I do know that where you could see the join across here, an angle that it was uneven when I measured the thickness here at both ends. There was quite a difference between one end to the other, so I know that I need to machine through the centre part of this first and then bring the cutter across to the other side to level it all up. But I'll carry on with this and then I'll bring you back to see what the progress is. Well, I've machined down this face now. I think we've got a sort of a reasonable finish to start off with. I seem to have a little bit of sort of chatter really on this, and I actually changed the 4-flute end mill to a 2-flute, which seems to have given me a better surface basically. I guess the most important thing is that this surface and the surface on the other end are parallel to one another. Obviously that's very important. On this face, the sort of rear end cap goes on here. I mean, if that surface was not completely flat, it would still seal, because between the end cap and the surface here there is a gasket goes in here, so that should stop any possible leaks through the back here. But it does seem to be okay to touch it. Although it looks pretty awful really, because of end mill machining it, whether I would have got a better surface possibly using a fly cutter, but from my experience a little bit more difficult to control. So anyway, what I've got to do now is have a bit of a clean up first, and then turn this over to machine the other side. Hopefully I'm going to have enough room below here and the top to be able to get a micrometer or at least my a digital gauge in to measure off the height, to get it as accurate as I possibly can. I'm hoping that I might just about be able to get my gauge under here, although the problem is it's over an inch, so that might be difficult. I have to see whether the next size micrometer would actually fit to be able to take a measurement or not. I can't really move this really towards the edge because the V block is, if you like, sort of standing each side of the slot in the bottom of the vise. But anyway, I'll get that set up and then just show you what sort of setup I've got to machine the reverse side of this. Right, well, I've reversed it round. Obviously I cleaned up around the edge of the bit I'd machined, just to take any sharp edges off, and I've done a bit of measuring with it, and I reckon I need to take off from this surface about 93 thousandths to bring it down to the 1.125. This time round I've got it mounted onto two parallels in the bottom of the vise here, so that I'm starting hopefully off with a nice flat surface below, so that I'm going to get hopefully a nice sort of parallel machined face here against the other side. So I'm hoping this is going to work out. I've got it mounted in the vise nice and tightly, and I've mounted it as I did before, to get it so that the 2 points of the V cut on the vise here grip between these features that are sort of cast into the cylinder itself. So I'm hoping I've got a good grip on it. So I brought the cutter down to the surface here. I put a piece of the usual cigarette paper in here just to take a sort of a reading off, and I've zeroed the Z-axis on the DRO. So I'm going to machine down probably to about, I suppose, about 90,000, and then sort of take some measurements. I don't think I'll be able to get a micrometer under here, but I've tested this out, and I can get my my digital caliper in here, so I can make some measurements when I'm obviously sort of near to the right cut depth. So I'll just do a bit of this on camera, and then the rest of it I'm going to do off camera, because I've obviously got to concentrate very carefully on what I'm doing here to get this as accurate as I possibly can. So here goes. Okay, I'll carry on with this, and because it's going to be quite a long job, and I'll bring you back when I'm nearer to size. Well, I didn't show all of the machining of this. I sort of concentrated very hard to try and get the measurement here absolutely correct. And while I was machining this down to this, I'd machine that side and then machining this side down to length. I was able to get the my digital caliper in through here to make the measurements, and if I set this up, and bring that in, there we go. I'm sort of dead on size. I'm sort of dead in the centre here as well, but that is the measurement that I needed, 1.125, 1 1/8. So I don't know how I ever managed to get it exactly to that size, but luckily I did. That's the absolute measurement that I needed. So that's the first job on this. So that's that part's sort of finished now. But I've still got sort of around about 5 other things to do on this. On the top here, this little projection on the top, you see there's I don't know if you can see that clear, there's a little bit above here as well. That's probably better, isn't it? A little bit above here, which it was basically part of the gate where the bronze was poured into the mould. So I will need to set this up in the milling machine and machine this surface down to that level there. You see, I did try filing this down a little bit on the top here, because I had originally proposed to use that as a surface to hold it in the vise, but I decided against that, because when I took sort of various measurements, it didn't seem right to me. So that's why I clamped it across here, actually at a slight angle. There's quite a lot of other things to do. Obviously the air and exhaust ports need to be drilled in as well. There'll be a couple of holes drilled through the top here, one each side here, which will be drilled down to sort of round about this position here. So there'll be one on that side, one on that side, and then there'll be a hole drilled from once this is bored out to the 1/2 inch size. There'll be a hole drilled from the sort of top surface here across at an angle to intersect with the hole on this side, and a similar one on that side as well. So that gives you your air in and air in and air out positions. The air actually coming in through a hole that's drilled through here. So in fact, when these holes are drilled, the ends here will be capped off, and they'll be capped off with little grub screws on each side. So there'll be an air intake here and an air intake at the end here. That's the end of the hole, which will be drilled through here for the piston valve. So before you drill this to the 1/4 inch, you drill through with a smaller drill right the way through, and then the 1/4 inch reamed hole will be drilled through to sort of around about here. So that will form the piston valve part, and the little hole here. There'll be a thread on here and a hole here with a thread on the top to take the air in and air out tubes. So still quite a few things to do. I think one of the dicey things is going to be not particularly drilling the hole down here. That's reasonably straightforward, but arranging to drill the hole from here I think at a 20-degree angle across here to intersect with that hole is going to be quite a dicey job, so not looking forward to that bit particularly. The difficult job I think is going to be boring or drilling the half-inch hole here for the piston, because looking at the position of this hole, it to me by eye looks as though it's over this side a bit too far. So quite how I'm going to do that, I'm not sure. I think setting this up in a 4-jaw chuck on the lathe is one possibility, and then drilling through. But I'm rather worried that as you would drill through here, that this hole will pull a drill off centre. I'm wondering whether I'd be better using a boring head to bore this out to the right size. Set this up in the milling vise, get it all lovely and squared up, and then find the absolute centre across here, and then bore through that hole. That might be the answer. I've not got a lot of experience of using a boring head, I must confess, so that's something I'd be rather worried about doing, but that may be the only way to do it. But it does mean that if I was able to do that, I would already have the boring head set at the right position, sort of perpendicular position here, which would mean I could easily then measure across here to drill the hole for the piston valve. I could get a more accurate measurement. Anyway, I'm going to have to think about that a bit. That may be the way I'll have to do it. So after this is all completed, I think in another episode I'll be doing the end caps. This one will fit on that side. There's a little projection here again. That was the sort of gate for the casting, so that will fit on here. And then this one will fit on that side. They are slightly different diameters, these, but I think that one only needs to be faced off, and then a little step put in, a little projection here which will fit inside the board hole on that side. But I think this one, from the plans, you do bring this actually outside part down to size, because that is actually slightly wider than that, so I guess that's brought down to size. But yeah, we'll sort that out when we get nearer to it. So well, I'll probably try and bring you back for some of the other bits of machining on this. So this particular episode obviously going to be a little bit longer, but I'd like to sort of complete at least the cylinder in this section if I possibly can. So I'll bring you back. What I want to try next is actually drilling and reaming the bore hole here to 1/2 inch. I spent quite a bit of time setting this up in the mill vise, and to my surprise, if I raise the head of the mill up high enough, I can get the 1/2 inch reamer in. It's the 1/2 inch reamer, and it's in 2 sleeves, one reducing the one at Morse table 1 to 2 and 2 to 3. So this will go directly into the head of the mill, and I am going to have enough height to do this. I've searched through all the stub drills that I've got, and I've found luckily a drill which I think will do the job. This one is 29/64, which is sort of roughly the size under ½ inch. I've chosen a stub drill because I'm hoping that if I bring the drill down very gently against the hole that's already here, if this is slightly off centre, it will cut correctly. And I'm hoping, as it's a stub drill which can go into the chuck as far as I can mount it, will hold the drill nice and firmly in place. I mean, I've drilled and reamed ½ inch holes quite a number of times when I've made small engines, but I've usually done this on the lathe, but I think it's going to be a pretty hard job to mount this in the lathe accurately. It can be done, but it's not going to be that easy. So what I've done is I've drawn in fact a Sharpie line down here to give me a guide to plot the pattern seam here at both ends, to give me a bit of a guide. Now the diameter of the cylinder here is exactly 1 inch. So what I've done is set up this in the mill vise, and I've actually simply used a ruler set across here at 1 inch, and then I set a pointer up at the ½ inch position, and then use that to set this up as square as I can possibly get it. Now what I've also done to try and check that I've got everything sort of, if you like, square to the hole, is I've put a piece of ½ inch silver steel in here. I've measured this as well, and this is exactly ½ inch. So I've brought that down against the cylinder, and then I've taken measurements across here, and across the back as well, and I'm exactly the same all round here. So I'm hoping this is going to work. I clamp this in the vise as tightly as I dare, so that I hope that nothing's going to move while I try drilling this. So the procedure basically is, if I remove this bit of silver steel and then put the stub drill in, and I'm going to try and put this into the drill chuck as high up as it will go safely, so that there's hopefully the less possible chance of the drill bending. I think it's quite a hefty drill, so I'm hoping that that's not likely to happen. And then I'm going to use the fine feed to start this off, not use the levers on the mill, because if I misjudged it and pressed that into this too hard, it might grab. So I think the thing to do is to bring this down over the hole here, lock the lever in position, and then go down using the fine feed, and I'm hoping that this is going to work and give me an accurate hole in here. So I'll just double check everything and then bring you back. Okay, keep your fingers crossed that this is going to work. Well, it's protesting a bit, but it is cutting. It looks like I think now I've got the hole established. I can probably use the manual feed on it now, but by the screeching noise it was making, I guess it needs to be a good steady cut all the way through. But it does look as though it's working okay. So I'll carry on with this and bring you back after I've got through at least with the drill. Well, I've got through with the drill okay. It looks all right. So now with the reamer, I've got the reamer mounted in, and I'm pleased that I've got sufficient room. I didn't think that this was all going to fit in here, but it does seem to work okay for me. So I'm just hoping that the reamer's going to go through not as easily, but in a similar way to the drill. The drill really was screeching when I started, but I think that possibly could have been that I was obviously using the fine feed. That may have been a bit too much for it, and when I switched to using the hand wheel, it did seem to go through a lot easier. So I think for this operation I'm just going to take as much care as I can and use the hand wheel again. By eye it looks like it's lining up okay, so I'm hoping that I can do this. I'm using some lubricant which on all the other machining processes I haven't bothered to do, but I think this is slightly different, so I'm just using some WD-40, which I hope will help the reamer through. I did use that with the drill as well, so let's see how we get on with this. I mentioned before, the problem I've got with the milling machine is that I don't seem to be able to run the milling machine very slow. You find that you get a very uneven sort of run of the motor at low speed, so I've got to just try and set it so that it's running fairly smoothly and just hope that it all works okay. So let's get on with it. got a bit of a build up of swarf in the reamer there. Let's just try and clean that out a bit. Just blow a bit of a let's go in again. Well, we're through, so I'm just hoping that's it's going to be okay. Obviously I'll have to examine that and see how it looks inside. Does seem quite smooth in there, so I have to examine this now and see how I've got on. Let's hope it's worked out okay. Well, as I say, I hope that's worked okay. That's my little gauge. This is a piece of exact 1/2 inch silver steel, and that. I'm only going to try this in the top. It does go in okay, so hopefully that's okay. Now, before I remove this, what I want to do is to mark out the position for the piston valve here. The centres for this, from the centre here to the centre of where the piston valve goes, is 3/4 of an inch, 0.750. I can't drill this all the way through at the moment because each side of this are resting on the base of the mill vise. So what I'm going to do is move this across, take a test measurement, and then just mark the position. Then I can reset it up and use that marked position to line it up to drill through for the 1/4 inch reamed hole. So I've replaced the reamer with the drill chuck. So that obviously will centre through here, and use the DRO to give me that measurement across in the X direction. So we'll 0 up X, bring that down, got to unlock the X movement on the table and move that across 3/4 of an inch. Here we are, 0.750. Let's just lock that. I'll bring that down. Obviously, this is just I haven't got a point marked on there, but if I roughly estimate that does visually look okay. So what I'll do is just replace the pointer with a centre drill, and then just make a little mark in here so I've got something to line it up with. Right, so I just put a little witness mark in there, and then I can then reposition all of this so I've got clearance below. I think that'll be okay actually. I think that's deep enough to give me that a marking. So I'll remove the cylinder, give the vice a nice clean up, and then I can move that over the hole in the sort of bottom of the vice to drill the next hole now. Right, well, the next job is drilling and reaming a hole here, 1/4-inch reamed hole for the piston valve. So I moved the bed of the mill across here 3/4 of an inch, and I made a tiny little witness mark here. So I can proceed now and bring the centre drill down just to give a guide position here. I've got to drill all the way through with a 5/32 drill, because the reamed 1/4-inch hole only goes down 1 inch into here. That'll all get sort of explained later on, so bear with me while we set all this up. Okay, I've actually mounted this up on parallels, because where I'd drilled and reamed through here for the piston, it's left quite a bad burr on the bottom, which I haven't been able to clean it all up completely yet. So at least the parallels will give me a nice flat surface that this is mounted on. And I've twisted the parallels in slightly as well, so that they support the cylinder nicely in position. That's okay, we're all the way through with the 5/32 drill. Now set up with the 15/64 drill, and we'll drill down here 1 inch deep. Okay, we'll go down now with the drill for reaming the hole as well. That's it. I've used the DRO to get the measurement, but I also put a little Sharpie mark on the drill as well, just to warn me when I'm getting near to size, but that should be okay. And I'm hoping that the inch depth on here, that all of that isn't necessarily needed, because obviously you've got the point of the drill to take into consideration. Also the fact that you're also going to be reaming into a blind hole as well, so everything that's for you is against you with this. Get the reamer in nice and tight. Nice complete reamer. Okay, we'll use a little bit of a WD-40 on this as well. Hope that helps a bit. That's shocking. The Z movements, give myself a bit of a guide as well. And again, I've got this problem of trying to run the seems to be the right depth, so hopefully that's all okay. It's quite warm now. Let's take the reamer out. So that's those two operations done. So we've now got a bit of cleaning up to do on that. There's still quite a lot of other things to do on this actually, so I think I'll save that for my next video, because all of those other operations are going to take quite a lot of time as well, and I don't want to make this video too long. I think it's long enough already. So again, many thanks for joining me in the workshop and working along with me while we machine this part out. So you see I've got the smaller hole here, which will ultimately be threaded, and we've got our two reamed holes, 1/2 inch and 1/4 inch, so we've got one for the piston and one for the piston valve, but there's still a number of operations to do on this, but I've got quite a sort of a hefty burr on the back of that, so I've got to just find a suitable way of cleaning that up. I've got some of it off, but not really enough to lay it down flat in the vise. That's why I've used the couple of parallels. What I have done off camera is I've just flattened that surface down here, so that will also be drilled with a couple of holes here as well later on. So thanks very much for joining me in the workshop. Again, thanks to all the subscribers to the channel and all the sort of nice comments I'm receiving through this series. But I think by far this is probably been about the most nerve-wracking part to machine. But I think the worst is yet to come, where I've got to drill the air paths through this. There's got to be drilled holes in a couple of different directions, so that's got to be tackled in the next video, I think. Anyway, thanks very much again, and I'll see you on the next video. Bye for now.